Hey guys, welcome to Section 7, Chapter 9 of the Pre-Algebra program entitled Similar Triangles. And this is our very last section for this course. Yay, you did it! You're almost done. I'm so proud of you. So we are going to finish up this chapter. You're going to take your final test, and then you guys are going to be free. So in this section, it's super fun and easy, and you'll explore more of this later on, both in Algebra 1 and in geometry. But we're going to use something that we learned in the first semester regarding proportions and applying them to similar triangles. So if you remember, we would have something like 3 over 4, and that equals x over 8. And we multiplied cross products to solve for x. So we would have done 4 times x, which is 4x. And that's going to equal 3 times 8, which is 24. And then we just had a simple one-step equation, and we could get x was equal to 6. So those were the proportions that we dealt with before. We're going to use that now in regards to similar triangles. So let's say we had a triangle, looks a little something like this, and then a smaller one that looks like this. And let's say that these corresponding angles were the same. And what these marks mean is that this angle is the same as this angle. And this one that has 2 is the same as this one that has 2. And this one that has 3 is the same as this one that has 3. Those are called congruent angles. Okay, and let's say we know a couple of side lengths here. Let's say that one's 3. This one is 5.5. Let's say this one is 2, and this one is x. Okay, if we wanted to solve for x, we're going to set up a proportion such that each side is put with its corresponding side. So what I mean by that is that when I see this side here, it's between the angle with 1 dash and the angle with 3 dashes. That has to go with the same side of the second triangle, also between the 1 dash and the 3 dash. So 3 has to go with 2 because they represent the same corresponding sides of the triangle. Similarly, 5.5 is between the 2 and the 3. And that has to go with x, which is also between the 2 and the 3. So it's very important that you set up appropriately the corresponding sides, otherwise your proportion will not be correct. But once you get your proportion written, then you're going to just take the cross products like we did before. So 3 times x equals 3x. And 2 times 5.5 equals 11. Excuse me. And if you divide both sides by 3, then x equals 11 thirds, or something like 3.7 if you did it on your calculator. Okay. All right, not too bad. Let's do another example. Let's say we had a triangle. Again, something similar to what we had before. And this time, this angle goes with this one, this angle goes with this angle, and 3 also goes down here. And I knew that this was 12, and this was x. This was 8, and this was 6. Okay, make sure that you're matching up appropriately corresponding sides. So this is my long side. It's between the 1 and the 2. That has to go with this long side, also between the 1 and the 2. So I know that 12 goes with 8. And then the x is between the 1 and the 3. That goes with the 6, which is also between the 1 and the 3. Okay, and then we're going to take cross products. So 8x equals 72. And then we do our simple one-step equation, and x is going to equal 9. All right, if you happen to miswrite it or write, let's see, you could have done x over 6 first. That is also the same thing as 12 over 8. So I'm writing, and typically we read left to right. But if for some reason, if the triangles are kind of positioned strangely or whatever, and maybe your brain would just look at the bottom first, that's totally fine. It doesn't matter which order you write it in as long as you put the corresponding sides correctly. And also recognize that for me, if I call this my left triangle, and this is my right triangle, my left triangle is on top and my right triangle is on the bottom. So you not only have to pay attention to their corresponding sides, but make sure that you write them correctly in their proportion. So if you write the left-handed triangle on top first, then you have to do that on the second proportion. And similarly, if you happen to write the right on top, then you would need to make sure that the right is also on top on the second. Okay, let's go ahead and do another example. Let's make this one a little bit oblong here. All right, let's say that this one is 1, 2, 3, 1, 2, 3. And this time the long side is 20, and this is 8. This is x, and this is 4. Okay, your examples are going to be pretty straightforward. They should be pretty easy to match up. The long side here is 20, and that matches the long side over there, which is x. And then my bottom side, again, between the 1 and the 3, corresponds with the 1 and the 3 here. So 8 goes with 4. Then we cross multiply. Get 8x equals 80, and x equals 10. All right, not too bad, I don't think. Let's do one other type. I think that you see one other type of example in your homework. I just want to kind of explain it to you. I think that there's an example in the book, but you know, you can't have too many examples, I don't think, in math. So hopefully this will make sense to you. But sometimes we put the triangle inside the triangle. So in my first 3 examples, I separated the triangles out. They were easier to see, right? But now I have a triangle inside the triangle. Okay, so I'm going to show you how to do this in 2 ways. For some people, it'll be easier to see the first way, and if not, then I'm going to give you an alternative. Okay, similarly as before, we need to recognize we have a big triangle here on the outside, which has a base of x and a side length here of 9. And then we have an inside triangle here with base 4 and 6. Okay, so the bases are probably the easiest to see. I see my small base 4 has to align with my larger base x. And then I'm going to look at my side lengths, and I started with my smaller triangle on top, so I need to put my smaller side on top and then my long side on the bottom. Okay, then you could cross multiply. Get 6x equals 36, and x is going to equal 6. Okay, say this wasn't very clear to you though. You struggled to see the triangle inside the triangle. One thing that you're going to be able to do as you continue to study this in further math courses is you can actually just separate those triangles out. Let's draw the big triangle. The big triangle had a bottom x and a side length of 9. And then the smaller triangle had a bottom of 4 and a side of 6. So now we have the same type of problem like we had before. It might be easier for you to see. So again, the bottom of the big has to go with the bottom of the small. And then the side of the big goes with the side of the small. Notice again here, I did small on top and large on bottom. But the way that I have this one written, it's large on top and small on the bottom. And that's okay. This is okay because one of the rules that we learned a long time ago was that multiplication is called commutative, which means the order doesn't matter. So as long as you are setting up your proportions appropriately, using the corresponding sides, and being consistent with what triangle is on top and what's on bottom, then the order that you write it in doesn't matter. And you'll see that here. Because again, I get 6x equals 36 and x equals 6. So as long as we follow the rules, we should all get the same answer. Okay, you guys, that's it. We just have a few of these problems. It's not very much, not too difficult. So I want you to go ahead and read through the examples, finish up your notes, and begin your final assignment before your last test. All right, you guys, take care. God bless. It's been a pleasure. Thanks for hanging out with me this year, and hopefully we can do it again next.